Okay, so next question is the second one, which is based on law of conservation of energy and momentum. So see, what we'll do is we'll try to solve this question in two ways. One, we'll try to do is using the concepts that we learned in loss of motion. Two, we'll try to do it using work energy theorem. Okay. So in this question, let's try to first solve this question using loss of motion. Okay. So what is statement one? A truck and a car moving with same kinetic energy. So we have a truck and a car, same kinetic energy. So KE1 and KE2 are the two kinetic energy, and we can say that this is equal to KE1. Are brought to rest by applying brakes which provide equal retarding forces. So we have braking force 1 and braking force 2. Okay, both come to rest in equal distance is the claim. So we go for the hypothesis that S1 is equal to S2. All right, let's see how and let's see why. Oh, if at all they are. So if I were to go with the free body diagram of the car, right? Because free body diagram of the car, I can say that the only force acting here is the braking force, and the net direction of motion is towards the right, right? Okay. Now, if we combine the free body diagram and apply second law of motion, we know that since this car is moving only in the horizontal direction, there is no motion in the vertical direction. Therefore, sigma Fy will be equal to 0. And sigma Fx will be equal to m into Ax. Now, what is sigma Fx? Sigma Fx implies sum of all the forces acting in the x direction. Now, this is the initial condition of the car. This is the final condition. Since it is coming to rest in equal distance, we can say that the final velocity is equal to 0 and initial velocity is equal to u. Now, since the braking force is applied, we can say that sigma Fx is equal to Bf. But what we need to understand is the net direction of motion is towards the right and braking force is applied towards the left. Therefore, while considering sigma Fx, we need to consider the direction which is minus Bf. So we have minus Bf is equal to m1 a1. Why? Mass of the car we have taken it to be as m1. Ax is a1 for the car. Okay. So what is a1 from here? A1 here is, my bad, it's minus Bf by m1. Okay. So I'm not including any concepts from work energy power. All what we learned is, or all we have applied is the concept that we learned in, the concepts that we have learned in loss of motion. Now let's see the same case with truck. As we have it in car, for the truck, the only force acting in the x direction is the braking force, and net direction of motion is also towards the right. Initial condition, final condition, truck comes to rest. There is no motion in the y direction. The motion is restricted along the x direction. Therefore, sigma Fy is equal to 0, and we have sigma Fx is equal to m into Ax. This time it would be m2 a2, and sigma Fx, sum of all the forces acting in the x direction. There is only one force which is acting in the x direction, and since the net direction of motion is towards the right, we'll take all the forces acting towards the right as positive, and we'll take all the forces acting towards the left as negative, and therefore we have Bf is negative, and therefore Pf would be equal to minus Bf will be equal to m2 a2, and a2 is therefore minus Bf by m2, right? Now what we'll do is we'll bring these two concepts together, and what do we get by that? So from the car, we found out that A1 is equal to minus Bf by M1. And what is A2 is equal to? A2 is equal to minus Bf by M2, right? Now we'll apply Newton's equations of motion. V square minus U square is equal to 2As in both the cases, okay? So the first case we have Vc, which is velocity of car, Vc minus Uc, final velocity of car minus initial velocity of car, and similarly final velocity of truck minus initial velocity of truck. In both cases, Vc and Vt, what are they equal to? They're equal to 0. So final velocity is equal to 0. Why? Because they are coming to rest. Therefore, what we get is Uc square is minus Uc square is equal to 2 into A1 into S, minus Ut square is equal to 2 into A2 into S2. What have we derived from now? We have derived that A1, right? We have derived that A1 is equal to minus B1 by M1, minus Bf by M1. So we have A1 is equal to minus BF by M1. And what is A2? A2 is minus BF by M2. Now I'll do a slight rearrangement here. I'll take this 2 to the LHS. I'll take this 2 to the LHS. So what we have is minus UC square by 2 is equal to minus BF by M1 into S1, and minus UT square by 2 is equal to minus BF by M2 into S2. See, now those who are figuring out, just trying to figure out the relationship between work energy theorem and this question, you have the answer right away. Well, I'm not going to solve it in that way because just for you to think. So pause the video here. Try to think how could you derive with the same equation using work energy and power. I repeat, the answer lies here. Okay, all right. Now we'll continue here. So we have minus UC square by 2, right, and minus BF by M1. See, what I'll do is I'll take this M1 to the LHS. So we have M1 into UC square by 2. I'll cancel off these two negatives. So this negative by negative becomes positive, negative becomes positive, right? Similarly, if I transpose M2 to the LHS, M2 into UT or U2 square by 2 is equal to minus BF. Okay, cancel off this minus here. S2, right? Now, what is M1 UN square by 2? Half M1 UN square is exactly half M1 UN square is kinetic energy of car. Initial kinetic energy. What is M2 U2 square? It is initial kinetic energy of truck. Now, if you divide these two, what you get is kinetic energy 1, right? I'll just go a bit more further. Yeah. So what you get is kinetic energy 1, M1 U1 square by 2, kinetic energy 1, by M2 U2 square by kinetic energy 2 is equal to BF by BF is 1. Of course, I forgot to cancel out this. That becomes 1. And all we get is S1 by S2, right? By S1 by S2. And what does this imply? This implies that BF by BF will now become 1. So it is given, we could derive that KE1 by KE2 is equal to S1 by S2. But what is given in the question? It is given in the question that the cars have the same kinetic energy. And if cars have the same kinetic energy, then KE1 by KE2 should be equal to 1. And therefore, S1 by S2 should be equal to 1, which implies S2 should be equal to S1. And therefore, both of them will come to rest in the same equal distance. Okay, so that's statement number 1. Now let's see what happens in statement number 2. A kind of tricky statement, I would say. Statement 2, a car moving towards the east makes, so let us try to visualize this. So a car is moving towards the east and it takes a turn and move towards the north, right? See, you can visualize this in two ways, and based on which the explanation would vary. So if I have to draw it like this is how it will go, right? Come to a rest, or maybe turn very slowly and then go like this at 90 degree. Okay, or what it can do is it can turn like this. Right? Induce a circular motion there. Why is the word circular motion important? We'll come to it in a while. So, a car moving towards east takes a move towards the north. The speed remains unchanged. The acceleration of the car is 0. Is the statement. Let's see. When an object changes the direction while maintaining the same speed, it undergoes a change in the velocity. Why? Because velocity is a vector, right? Velocity is a vector. It will have both magnitude as well as direction. Due to the change in direction, since acceleration is the rate of change of velocity, the car experiences what? Don't go any further. The car experiences what? The car will definitely experience a what kind of force? It will experience a force that will act towards the center. Yes. What kind of force? Exactly. What we call as the centripetal force, and therefore it will attain a directional acceleration, even though the speed remains constant, right? Which means the body would try to produce a motion which would tend like this, right? It will try to induce a what kind of force? It will try to induce a centripetal force here. Okay. Therefore, it can be concluded that the statement is incorrect. Why? Because the acceleration of the car is not zero. It has a centripetal acceleration due to the change in direction. So statement 2 is false, while statement 1 was correct. Okay. All right. So that's it. So let's now move on to the next question.